around looking, I saw some little mistakes that some of you made. So I'm actually going to do these problems on the board and just want to kind of remind you of some things. Y equals 2x minus 1. We haven't seen this type of function in a long time. This is a linear function, and Roger, what were you going to say? This is a y equals mx plus b. Very good. Y equals mx plus b. So why did we put this table up here? It's important to know that you can graph any function in the world using a table. Start plugging points in. Start plugging numbers in for x, getting a y value, and plotting that. But we can actually say, hey, look at our y-intercept is -1. And our slope is 2, so we rise up to round 1. So we have this function. X cubed. This was our parent function from last unit.
I know it's hard sometimes. Yeah, I think about the end just way too much. But it's fun to fantasize on my enemies.
X squared plus 1. X squared was our parent function from last unit, and that plus 1 does what to it? It moves it up 1. Very good. So we're going to take that.
I'm taking my time on my ride.
And many of you had it. I had to give you some little reminders. Overall, you were good. And now negative x squared, what does that one look like? Yeah, it's reflected. Very good. And this -1 does what, you guys? So the -1 here in front of the x squared reflects it. And then the -1 on the outside here does what to it? Moves it down 1.
Many bullets coming through. Too many bullets coming through, metaphorically.
And many of you guys had your tables filled out, which was great. You just didn't have the graph. So make sure you have the graph on all 4 of these right now. So take a second if you haven't.
Would you live for? Would you die for it? Would you ever kill?
And I am recording now just so you guys know. What I'd like you to do right now is I'd like you to take about 1 minute, and I'd like you to look at these 4 functions and say, how are these similar? How are they different? Okay? Try to generate a list as long as possible. How are these 4 functions similar? So now I want you to look at the function itself as well as the graph. Come up with a list as long as possible. How are these functions similar? How are these functions different? Okay, do that now for me. Similar, different.
Thinking too much. I've been thinking too much.
Okay, so I'm going to time you. I want you to take 2 minutes on your own, and then I'm going to have you partner up.
I've been thinking too much. I've been thinking too much. Help me. I've been thinking too much. Help me.
1 more minute on your own, and then I'll be partner up.
Thinking too much. I've been thinking too much. Help me. I've been thinking too much. I've been thinking too much. I've been thinking too much. Help me.
You guys are doing such a nice job of writing on me. I'll give you a little bit longer here. Very good.
So you're still thinking of me, just like I know you should. I cannot give you everything, you know I wish I could. I'm so high at the moment, I'm so caught up in this. Yeah, we're just young, dumb, and broke.
All right, I want you guys to share with your partner. What did you guys generate? So you two go together. You two, Sam, you with Sean. You two, Jason, you two. Three, why don't you move up to the 3? You guys can go together. And then you 3. Okay, and then you 2. Right? So So talk for about a minute or two. What did you say? What did you find out?
What did you say?
If you don't know each other, say hi, my name is. I didn't say you know each other by now. That's it. Say hi, my name is.
Girl, I saw all that. You're lying.
What do you have?
The second, third, and fourth.
Naga, what do you have?
Do you guys all know each other here?
Yeah.
Okay. Okay. Let's make this try.
Yeah, I had to.
Okay. Let's hear from you. It's quieting down now. John, let's hear from one thing. What did you guys say? What's one thing that's similar about them?
I want to see the left two will all have all real ranges.
Oh, okay. So the left two have all real ranges. So if you look at the range, they're all real numbers. What about the domains? All real for all of them. Very good. Okay, so that would leave us, if these two for the ranges have all real numbers, what are these? One's y is greater than 0, or y is greater than 1, and the other one's y is less than or equal to 1. Good observation. Isabel, what's one thing you just talked about?
That
Okay, good observation. So the first two were going opposite directions, and the other two, they're both going the same directions with the way. Now, when you say that, you're talking about like the ends, right? Very good, very good. Matthew, right?
Yeah.
What did you guys talk about?
All of them end in arrow.
All of them end in arrows. Good observation. Heidi, what did you guys talk about?
3 and 4.
Both U-shaped. Okay. What about someone who, is there something we haven't said yet? Yeah, Matthew?
2, 3, and 4 are parent functions.
2, 3, and 4 are parent functions from our last one. Good observation. I think I heard someone talking about the exponents. Did anyone talk about the exponents?
I wanna follow where she goes.
I'm forgetting the term. It's an exponent. The other.
The degree. Yeah, the degree. What about it?
Wait.
What do you notice about these exponents compared to these exponents? Yeah, we have odd degrees and we have even degrees. All of these things, this list of items that we've generated, have what our learning target is today, or they're involved with what our learning target is today. I'm sorry, I can describe the end behavior of a function, okay? And then use what I know to graph a possible function. And the end behavior is what's happening in the ends of the graph. And that's really important as we get towards calculus, as we do something called limits. We need to know how to evaluate end behavior, because once we get to calculus, we're going to have to describe that end behavior, which will eventually link to what we call a derivative. Okay, but first we just have to be able to describe the end behavior using technical terms. So I'd like you to go to your next page and I'll give you a little instruction on how we describe end behavior. When we're describing end behavior today, you're going to see a template on your homework. Okay? And that template on your homework is going to look like this. So everyone make sure you're on the right page. And how we read this is I have it written down, the first line here, in red. In red. Sorry. In red. Okay? What we say is we say as x, this arrow in math means approaches. So as x approaches negative infinity, f of x approaches blank. And you're going to have to fill in the arrow, and I have that written here. As x approaches negative infinity. That means really, when I look at my x and y axis, so here's my x, here's my y, right? Negative infinity is over here. If I was going to plug values into my x, negative infinity, as my numbers get bigger and bigger, what's happening to my y? That's what this is saying. We want to analyze what's happening. And if the graph is going up, so we're going to fill the blank in. So write down what I'm doing right now, because you've never had a packet for notes before, so let's do a little bit. Right? Just a little bit for you guys. So as x approaches negative infinity, the function approaches, you're going to have to fill in this blank right here. This is the same blank. And you're going to say, is the function ending up? And if it's ending up, we say positive infinity. Or is the function ending down? And if it's down, we say negative infinity. And then we're going to look at, now I'm going to underline the green side. As x approaches positive infinity here, f of x approaches what? How is the graph ending? That's our goal today. We want to see, in the end, what's happening to these arrows. Where are they going? Okay? Where are these arrows going? So it's either going to go up or down again. Write a blank in. If it ends up going up, we say positive infinity. If it ends up going down, we say negative infinity. So I'm going to show you how to apply that now with the 3 graphs below.
My brain, oh, it's such a shame. We don't talk anymore.
So if you're asked to analyze the end behavior of a graph, you're going to be given a graph. Okay? For example, here's my graph. And you're going to be asked to fill in a statement. So write with me under, as x approaches negative infinity. So negative infinity is as my x values get bigger and bigger and bigger towards the negative values. So over here, right? What's happening to my graph in the end? It's going up. So as x approaches negative infinity, that's on the left side. So you can feel that negative infinity over there on your graph. Right? Negative infinity is on my left side, so fill it in. As x approaches negative infinity, f of x approaches, well, it's going up. So we're going to put what? We're going to put positive infinity, or just infinity. That's fine as well. We have to do both sides. So I did red, and now I'm going to do green. As x approaches positive infinity, f of x approaches. Now, positive infinity for the x is on the right side. What's happening to my function? It's going up again. I want you to try this one on, or do you want me to, why don't I do one more with you? Then I'll do one on your own. Negative infinity. Is everyone ready? As x approaches negative infinity. So where is my x approaching negative infinity? Over here. As my x values keep getting bigger and bigger and bigger, what's happening to my function? Is it going up or down? It's going up in the end. So as x approaches negative infinity, f of x approaches what? It's going up, so what do we put?
Positive infinity.
Positive infinity, or just infinity is fine as well. As x approaches positive infinity, so the right side of my graph. What's happening to the graph in the end? It's going down. So negative infinity. I want you to try this last one on your own, please, and I'm going to walk around. Fill in the blanks. As x approaches negative infinity, don't say it out loud, f of x approaches blank. And as x approaches positive infinity, f of x approaches blank.
We should take this back to my place. That's what she said, back to my face.
looks like you guys have caught on pretty quick to the basics of just looking at the graph. Which way is it going? Just check the rest of yours. But we want to get a little more in depth. We want to be able to look at a function and say, I know what the end behavior is without even graphing it. We want to be able to look at a function and be able to describe or draw a possible graph. Okay? So that's the next step. And I think I checked all of yours and you had negative infinity for both. Okay, yes?
Have there been a time where like it's kind of like can't really tell?
Not for what I give you. There won't be. Okay, not for what I give you. When you get to pre-calc and calculus, instead of approaching infinity and negative infinity, it may approach like a number. So you'll get a graph where it's approaching, 3 or something else, but not in algebra 2. Algebra 2 will always be positive or negative infinity.
So like if it approached the number, like flatten out.
Yes, exactly. If it approaches the number, it will flatten out. That's great. Wonderful. Okay, I want you guys to draw. Go to the next page. These 4 graphs, graph 1, 2, 3, and 4. We want to dig deeper now. All of you could do it. Looking at the graph when I was walking around, you had negative infinities for both of them. You can describe that end behavior. But what I'd like you to do is dig a little bit deeper right now. And I'm going to tell you something. Function number 1. The degree of this function, what does the degree mean again? The highest exponent. The degree of this function is 1. If I would write it, it's a y equals x something, okay? The degree of this function, does anyone know just by looking at it? Yep, the degree, yeah, it's an x squared, very good. The degree is equal to 2. It's an x squared graph, very good. It's a quadratic graph. Graph number 3. It's a cubic function, very good. The degree is equal to 3. It's a y equals x. Does anyone know this one? Close. It's a 4. It's a 4. The degree here is a 4. It's a y equals x to the 4. Okay. I want you to, since we're a small group, let's type together. What do you guys notice, first of all, about the degree? Think in your head first, don't say it out loud. The degree and the number of x-intercepts.
Daily struggle. She tells him, ooh, love, no one's
The degree and the x-intercepts. What's the x-intercepts again? Where it what? Where it crosses the x-axis. How many times does it cross the x-axis here? 1. How many times does it cross here? 2.
I'm gonna rock you, rockabye.
3. Will it always happen that way? No. What do we know about this function, you guys? This still has 2 solutions, but what kind of solutions are these?
None.
Yeah, they're imaginary. Very good. But at most, the number of times it will cross the x-axis is the degree. Okay? Now I want to see, do you notice any differences between my odd functions and my even functions? Could you give me a sentence? Raise your hand when you notice a difference. So give everyone a second to think about it. So I have 3 people who notice a difference. What's the difference between my odd functions and my even functions? Raise your hand when you know.
in her eyes. He don't know he is safe when she's safe.
Jamari, what do you notice?
For the odds, they're going in 2 different directions.
For the odds, they're going in 2 different directions. Very good, very good. Okay, the odd functions are going in 2 different functions. So let's write that down. first row? Well, we learned the most number of times, am I saying that right? The most number of times that a graph will cross the x-intercept, or cross the x-axis, is the degree. 1, 2, 3, and 4. A fourth degree function will never cross at 5. Could it cross it 3 times? Yes, it could. Just like we learned that with x squared. Could a cubic function only cross it once? Yes, it could. But at the very most, it will be 3. Okay? What else did we learn? Well, we learned that the odd functions are ending in 2 different places, and the even functions are ending what? Even functions are ending the same direction. So let's write that down. Even functions now I want to change it up on you. Okay? I want to change it up on you. You guys ready? I think you are. You guys are doing a really good job. This bottom one, what's the degree? Yeah, the degree is 1. How do I know? Well, convince me. There's 1 point. Yep, it's 1 x-intercept. What's the degree on this function? 2 again, convince me. 2 x-intercepts. The degree again, 3, and then finally 4. Whoops, jumped ahead. Okay, now, what's different? Raise your hand when you notice what's different.
I hate you, I love you, I hate that I love you.
What's different? Raise your hand when you know what's different. Heidi, what's different? Oh, you raised it. Who else? Help her out. What? Isabel, did you notice the difference? Sean?
It's negative.
What do you mean it's negative?
It's like the y, when it would be y equals negative.
Y equals negative, because what? Y equals negative x. This would be y equals negative x squared. Y equals negative x cubed, and y equals, what is, how did you know it was a negative?
Opposite.
What does that mean? Yes, exactly, Heidi. Ah! Oh, okay. Hold on. Sean, go get some more. Okay. 1 second here. I got distracted. Okay, it was negative because we know that, lock it back up here, please. We know that a negative on the outside does what to a function? Reflects it over the x-axis. Very good. Reflects it over the... Now, I want you to look real quick. Do these rules still apply? Odd functions and in 2 different ways?
Yeah.
Yep, and even functions and what? The same. What's different about it? Only. Yeah, so on the right side here, we were going up, but now we're ending down on the right side. Could we go ahead and say that, do you remember what this number is called in the front? I hear it, I already hear it. Y is equal to x squared plus 2, let's put 3x squared plus 2. Can we go ahead and say for sure, if it's positive leading coefficient, on the right-hand side, it's going to end which way? Yeah. So let's write this down, guys, below or on the side. Again, we're not used to note sheets, so we're kind of all learning together. So on the same one where we have the what do you notice? What else did we notice? Well, we noticed on the right-hand side, if the leading coefficient is positive, look at all of these leading coefficients are positive. On the right-hand side, it's going to end which way? Going up. It doesn't matter the degree, just the leading coefficient. The leading coefficient here is all negative. And on the right-hand side, it ended going which way? Going down, yeah. On the right-hand side, it ended going down. So we can make the statement now. On the right-hand side, if the leading coefficient, L period C, do you know what I'm talking about by L period C? If the leading coefficient is positive, it goes up. If the leading coefficient is negative, it goes, what do I mean by it? The line, yeah, the line, the function. Well, why is that important? Well, our end goal here is we need to be able to graph a possible function. Okay, and we're going to use this piece as well. So let's go to the next page. Drawing possible graphs. Okay, drawing possible graphs. So we want to be able to describe the end behavior, and then we want to use what we know about end behavior to draw a possible graph. So that's this last page. Are we ready? Okay, and I have the steps already written out for you, which is kind of nice. Okay, so here is our first one.
I'ma care for you.
We have 2x to the 8th power plus 9x to the 7th plus 10. What is the degree of the function?
8.
Yeah, the degree of the function is 8. We learned that on Friday. So if you were gone, was anyone gone on Friday? Okay, so on Friday we learned that, so we'll have to get that in the notes. The leading the degree is 8. We've talked about leading coefficients from the beginning, so the first thing we're going to do is we're going to start on the right side of the graph. Look at the LC, the leading coefficient. If it's positive, we're going to end going up. So our leading coefficient is what? 2, and that is positive. So on the right-hand side, we're going to end which way? Going up. Step 1. Is everyone okay there? So if it was negative, we'd end going down. Your x-intercepts. Number 2. How many x-intercepts am I going to have? I'm going to have 8 x-intercepts. 1, 2, 3, 4, 5, 6, 7, 8. What? 8 possible. Yes, 8 possible. But right now we're just determining a possible graph. It's not an exact graph. That's where we'll get to. By the end, we'll get to an actual graph. Okay. Now we just plot them wherever. I'm not going to grade. Oh, it's an inch apart or it's a centimeter apart. It doesn't matter to me. Yes.
So the degree would be like infinity?
It will never be infinity. No. No. Good question, though. Okay, now I have it, and now the step 3 says to do what? Connect. And I'm just going to go like this, like a little roller coaster ride. Isn't it, though? And now we can check, too. Hey, is this degree odd or is it even? It's even. What did we say about even graphs? They end going which way? The same way. So we know we did it right. That's a way we can check. We know we did it right. And now we want to evaluate the end behavior. As x goes to the negative infinity, as x approaches negative infinity, that's over here. What's happening to the graph? Going up. Yeah, so positive infinity. That doesn't matter right now. So all we're talking about is we're connecting the degree and the leading coefficient. That's a good question. And then as x approaches positive infinity over here, where are we ending? Positive infinity. Okay, I'm going to walk around. I want you to try the next one on your own. So you're going to do the negative 3x to the 5th power. Step 1. Look at that leading coefficient. I'm going to walk around and check it when you're done.
You know I've been taking some time and I've been keeping to myself.
Okay. The coefficient is negative. On the right-hand side, we just said we're going to end which way? Going down in the negative area. So this is the negative area down here, guys, remember. Okay, in the negative area. How many times are we going to cross that x-axis? 5. 1, 2, 3, 4, 5. We're going to ride the roller coaster. It's an odd function, so we know it has to end. Odd is opposite. And now we can fill it in. All right, and now I want you all to stand up and we're going to do math yoga again. Everyone ready? Okay, stand up, so I want to check, I want to test you. I know some of you are very excited about this, but this is our second time doing math yoga. We're going to do it again. Okay, so look up at me. Can everyone see my hands? Yeah. We're all facing forward, so I'm your yoga teacher. Jackson's going to get up in a second, right, Jackson? Right. Come on, Jackson. We're waiting for you. Okay. This is so you can show me that you get it. Okay, ready? So my right hand is the x is going to positive infinity. My left hand, x is negative infinity, right? So positive, right? Negative on the board. So I'm going to put some functions up here, and they're going to get easy, and then they're going to get hard. So we need to, okay, look at me. We need to say, hey, the leading coefficient, so we know which way the right hand will go. And then what else do we have to look at? If the degree is, no, the degree is odd or even. So I'll put it on the board. Remember, we're going to look first at the leading coefficient. If it's positive, my right hand is going which way? Up. If it's negative, my right hand is going down. Next, I'm looking at the degree. If it's even, my hands are going in the what? Same direction. If it's odd, my hands are going in the opposite. Okay, I'm going to test you. They're going to get difficult. Are we ready? Okay, let's go.
Sure.
Y equals x squared. Let me see everyone's hands. Everyone's hands. Y equals x squared. Very good, okay? X cubed. Good. X cubed, right? Right hand side. Yep, good. Negative 5x to the 5th power. Okay, which way? You gotta think about it. First, we look at the leading coefficient. Good, I think, yep, and then it's opposite. Very good. Okay, let's do just a couple more. Let's get more difficult. Let's do, ooh. What's this, guys?
Pi?
Maybe, let's see. Oh, this is a trick one. Look up here.
But it's still like this.
Okay, wait, let's see. Okay, someone convince me why they're right on this one. Who knows?
Because I thought about it.
The degree is...
What is wrong with this function here?
The leading coefficient is not in front.
What do we call that when it's not in front like that?
Incorrect.
We're doing that.
Not math.
Oh, hi guys. Come on in. Okay. Okay, everyone sit down real quick. Sit down. Alright. Ladies and gentlemen. What was, you guys did an amazing job with that. What, yeah, let's talk about what's right in this one. What's wrong with this function here? It's out of order. Do you guys remember way back first semester? Sean, what does it mean when something's not in order?
Disorganized.
It's disorganized. Yes, it's disorganized. It's called not in standard form. Okay, it's not in standard form. So if I would rewrite it in standard form, how should I rewrite it?
Negative 8x to the 3rd.
8x.
Whoa.
Plus 7.
Plus 7.
Okay, now again. So what was the right way? I'm the yoga teacher. I have a leading coefficient that's negative, so my right hand needs to go down. And it's odd, so I need to end in opposite directions. Okay? Very good for those of you who got it right. Let's see. Why do I always forget the time that we...
14.
Oh my goodness, you guys, the time went so fast. Okay, here is what we need to do. Oh, 21. Anyone want to take a stab at it? Good. Okay, party over.
Over?
Here is your job. We only have 4 minutes. Let's not hold on.
Party crash.
Listen up. I am going to give you your packets. I want to give you a friendly reminder that part of the learning target for Unit 10 we did on Friday, the direct and synthetic substitution, because I knew we wouldn't be able to get through all of it in one day. So on your 5, eyes on me, lock in. Your 5.2 packet, it's going to have your end behavior on there, as well as what we did on Friday. Then you have your Schoology learning target quiz. I can evaluate end behavior. So those are the 2 things that you need to get done for tomorrow. Remember, when there's a learning target quiz, do you have to do all of your work on the packets? I would start with maybe, what would be a good suggestion? Do the odds, maybe. Do your learning target quiz. If you don't get it right, then what should you do? Go back to the packet, practice more. Exactly. All right. Let me stop this. Orchestra kids, how was the